First up, we have Alison Moss presenting dataVisEasy. Then we have Jess Streeter presenting Nerdify Your Life. We'll take a real quick break, and then we'll close out with Jake Riley presenting. I forgot to ask how to pronounce this one, actually, so I'll let Jake pronounce it. I think it's Rock QI, but I will let Jake tell us specifically. A little bit about Our Ladies Philly. We are the local Philly chapter of Our Ladies Global, which is a worldwide organization specifically that promotes gender diversity in the R community via meetups and mentorship in a friendly and safe environment. We welcome anybody who respects our code of conduct, which can be found here at ourladies.org/code of conduct. All of the links that you're going to see are, again, available at this tiny URL in the bottom right-hand corner here. So if you want more information, that's the place to go. But if you get a chance, the code of conduct is a good thing to review. Oops. Here we go. There's lots of ways to get involved with the Our Ladies Philly community. One would be joining our Slack community. Again, there's a link here, and you'll see, I'm sorry, I'm losing control. And in our Slack, there's lots of different channels where we post about Datathon, post about general things, job postings, our help. There's lots of channels and ways to get involved in our Slack. You can subscribe to our YouTube channel. Since we've gone virtual, I think for the last 7 months or so, all of our events have been recorded and posted on YouTube. So after today's event, you can go and rewatch this event. You can see our previous events. All of those are uploaded to YouTube after we finish the event. And then you can volunteer to come be a speaker at one of these events, or be a mentor or mentee at, or find a mentor if you're interested in being a mentee at this link, again, available in the tiny URL at the bottom. And a quick thanks to our sponsors, our consortium and Independence Media. You can also see on the bottom left-hand corner, if you want to live tweet any of what you see today, you can tag us at Our Ladies Philly on Twitter, #OurLadies. A couple of quick announcements. We have a few events coming up. I think you'll see in these in the chat that Carla posted a link to our end of year survey. If you could take that, that would be great. On January 18th, we're going to have an event to kind of talk about our New Year's resolutions, and we will use some of the data from that survey to incorporate into that event. And then in February, we have our 2022 Datathon kickoff. And then there's a Use Our 2022 conference coming up. Submissions open December 15th through February 15th of 2022. I guess it's 2021 for December 15th through Feb 2022. And just again, we're recording this meetup, so be mindful of your camera, please, because this will be posted to YouTube. And with that, I will hand it over to Alison Moss for her presentation of dataVisEasy. So a little bit about Alison. She recently graduated with her PhD from Thomas Jefferson University and is now working at Radiant Health as a computational biologist. She absolutely loves coding and gets way too much enjoyment out of writing and debugging functions to make data analysis and visualizations easy and consistent. Alison, you want to take it over?
Yeah, thank you so much. That was an awesome introduction. Let me see if I can share my screen. Okay, so I'm going to present to you guys the package that I have written throughout my PhD. Right, the working title is dataVisEasy, and the biggest goal is this integration of metadata and your data, just so you can consistently and accurately visualize things, and that you don't have to deal with a lot of hard coding and back-end work. This package, if you're interested, is available on my GitHub as well. A little bit of background about me and how this package got started. Jesse gave a lot of info already, but I just graduated from Thomas Jefferson University, and I was working in a systems biology lab. A lot of large expression data sets, analysis in R. I started with very little coding experience, and the lab I was in had both very experienced R users and a lot of beginners, so I was kind of in a mixed bag of people and things. But the project I was on, I was sort of filling a void for a lack of data analysts. So I came into a new project that required some very, very fast results, which meant I needed to learn R very, very quickly. So of course that meant I needed to prioritize, figuring out like what are my immediate tasks, like what analysis is going to be needed repeatedly, and the analysis of visualizations needed a lot of improvement. And then just right now, I just started a new job at a biotech startup. So that's been really fun. Just some brief background on the actual data set that spurred this code development so you can understand some of the visualizations a little bit more. A lot of my PhD work focused on neurons in the heart. So whole big thing that a lot of people didn't know, that there were neurons actually on the base of the heart. So our job was to characterize them. So this data set we're looking at consists of 405 single neurons that were collected with spatial tracking data, which is pretty cool. And those samples are from 4 different animals, 2 male, 2 female. They're also a tracer to identify neurons that are projecting to the SA node. Basically, all that means is this is just different metadata. So I have 4 different animals and I have 2 different cell types, basically. And we use high throughput qPCR to assay for about 230 genes. Sorry, it's stuck. Okay. So the biggest thing is with this is one of the things we needed to identify cell states, and as additional analysis, they really just needed a lot of visualizations, a lot of heat maps, statistical analysis between sample groups, and any other insights I could get. So task 1 for me was to make a heat map. So I started with pHeatmap, and if I just did a straight heat map of my data, it looked like this, which obviously was pretty crappy. There's like very little information we can get out of this. If I looked at a histogram of the data, I could see that the scale was totally wrong. Most of the data is between, like -3 and 3, and this scale goes from the absolute max to the absolute min. So already this was just not helpful. So my first thing I needed to do was just figure out how can I adapt this heat map to be useful. So the first things I really wanted to do is change the colors just so that they were clear and specify the range. So that got me to just this heat map, which is actually the same data, and just the colors are different, and I specified the range. In this case, I just went from data straight to heat map. A lot of this package ended up being sort of the whim of what my boss and other lab mates wanted. So you can see that that's like where a lot of this stuff ended up going. So in this case, went from data to heat map. And the next thing I was asked to do, why is this not? Was to basically subset the data for the heat map. So I said, okay, here's a list of genes. Don't give me the full heat map, give me a subset. So I figured out how to do that. But the biggest issue is every single time I had to do this, if I was hard coding it, I needed to go in, type in my genes, subset the data, then pass that data to the heat map function, which got really tedious. So now I had an extra layer. In addition to specifying colors and range, I needed to specify the subset for each thing. So this gave me my first iteration of my function, so I wouldn't have to physically subset it myself every time. So my first function started off with giving the function the data, giving it a list of genes I wanted it to pull out, as well as the range of the heat map and the colors. The next thing, of course, the next demand from the other people working on this project were please cluster it differently and order the samples differently. So I added another layer after subsetting is to cluster or reorder it. So in this case, I coded in different options. Options for how to correlate the data and cluster it, and different options for maybe the data needs to be ordered a certain way, and I can do it that way. So now I have even more things that I'm specifying in addition to what I had before. I'm also specifying clustering and giving an option to order by a certain gene, because that was asked a lot. My lab mate said, okay, we need to order by this gene. This one's important. So that led to my heat map function iteration number 2, which included clustering method and an option to order by gene. But the biggest thing that just kept getting annoying was I really need to specify all of these parameters. So we have all of these things I was trying to specify, and especially specifying the colors and the range got incredibly repetitive because for one data set, they're pretty much going to be the same every single time. And it was really annoying me. So because they're not going to change much with each data set, I spent a while trying to figure out how to basically make like a universal object, or it ended up being a list object that each function could call to. So this led me to the quote unquote params object, or my parameters object. So basically my goal with this was that you only have to set the things in the param object once. And once you set it, your functions will call to that object so you don't have to do it again. So far, I started off with my params object with just a range for the scale of the heat maps and the colors I wanted to use. So because I have the range and the colors getting from the params object, and clustering method and the gene ordering can be internal options and with defaults, I simplified this function. So iteration 3, the only things that were necessary were data and a subsetted list if that was what was desired. And the other things were either calling to the params object or we were getting a default. So you can see how I was sort of just iterating based off of need and just to make things simpler. With that, in addition to this was heat maps, but we're not just for heat maps right now. We also needed scatter plots. We needed B-swarm plots so we could see the range of things, and density plots. So for all of these had a pretty common theme. They're all based in ggplot, but the basic theme was that we had data plus a list of the genes eventually led to this plot. And a lot of the things that I did up front here was changing the ggplot themes just to make sure that it was what we wanted and a little bit more visually pleasing, and coding in the axes name. So if whatever you specified would give you the axes name out. So again, just trying to like minimize the legwork needed to produce a publication ready image, basically. But the biggest issue with this is that none of these visualizations actually communicate any of the associated metadata. So the ultimate task was to add a meaning to this data, because we have 4 different animals. We have a couple different sample types. There are so many different layers to this that we needed to add that in. So the quick option, of course, to color this stuff was to hard code each plot individually, which you can do in ggplot, of course, but that again just got very repetitive to have to add that in every time. So this is a pain. And again, just like the other things in the params object, that metadata will be consistent across all plots. So that brings me back to my params object, and I wanted to expand it. So instead of just taking in scale and colors, I now have sample annotations, gene annotations, and colored annotations that are in this object, so that every time I set this once, and it should call to this object for every visualization. So the important thing with this is that the sample and gene annotations are linked to the column name and row name, and the annotation colors are linked to the annotation name. So as long as all of these things are named the same, which they really should be for your data in the first place, it makes everything downstream a lot easier. And you only have to set all this once, and then especially the colors and everything will be consistent across all the plots and analysis. And this was a really big like leap for me and my coding journey, as well as getting all of this analysis done. And it was very helpful for the rest of my lab and everyone else too, who had similar issues all the time. So just like a quick, like, how do we do that? This is an example of our data set where we have our genes in the rows, and these are some moderately complicated sample names in the columns. And here's what our annotations look like, is we have our sample ID, we have all these other different metadata. I don't even think this is the whole thing. This is just a subset. But so we have all this metadata that we wanted to link. So the biggest thing is that the column names of my data and the row names of my annotations match. I don't think these are actually in the right order because they're just a subset, but important thing is that they match. And I made a function called set annotations. And if I just pass my annotations to that, it loads that into the params object. So then I don't have to think about it ever again. And I did the same thing for colors, and basically giving a note colors or annotation colors a list of the different annotations and what colors they should be. And one of the things here that I ended up finding is that there were some annotations that I didn't want to specify colors and just wanted to use the default. So it does give you the option. You don't have to specify everything. If you want to specify the colors, you can. If not, you don't have to. And the important thing here is that whatever you're listing for the colors, the name has to match your annotation name exactly. So basically, as long as everything's linked, you can set these things and not have to worry about it again. So now we have a lot more options. So I have my scattered genes function, which before I could just give it the data and the 2 genes I wanted to do a scatter plot by. But now if I just add color by and point to my annotation, it will immediately color by whatever colors I specified for and the annotation. And same thing if I wanted to just do by, this is transcriptional state instead of connectivity. So again, same data and it's just coloring it differently, but both of them are internally calling to that params object for annotations and coloring. So this, at least for me, was a huge thing just to not have to go back and do this every time. And I eventually went back and fixed the code so that even if the annotations and the data weren't in the same order, even if you subset the data for the annotations and everything, that as long as the names were the same, it would link everything and you wouldn't have to worry about anything in between. And we had the same thing for annotations with the bee swarm. So we have this original bee swarm plot that just shows us the distribution of 4 different genes. And the first thing I want to do is look at it, like separate it by color. So in this case, I've colored by the connectivity or this different cell type. And the default for this was actually to both color this way and to separate them and split them into groups by that. So I had a couple different options with that. I also could just group by that annotation instead of coloring it, or I could do the exact opposite. And in this case, because the default is to group by the annotation as well, if I said, okay, I don't want to group by that, but just color by that annotation, I can see how they're distributed together. And then the next step of that was to do both things and to actually split it up. And if I add a facet statement to that, I can choose to color by one thing and group by another. And while all these things are obviously things we can do in ggplot already, it really helped me to stick this into a function so that I could just very simply state the genes I wanted and which annotations I wanted it to be linked to and leave it at that. Going back to heat maps, actually, there are all sorts of different annotation tracks you can do in heat maps. So like I had mentioned earlier, we had way more annotations than we needed. And we have some of these like cap ID and section and a bunch of stuff that is super unnecessary. So I also added an option to basically indicate which annotations you wanted to be shown up here in the tracks. So this, again, internally calls this params object for annotations, the coloring, and to indicate which ones you want to show and not show. And so the heat maps were a really big part of our data analysis and our visualizations. So the next thing that I was asked to do was to separate these heat maps by their annotation. So this took a good amount of legwork to do also, because I was asked, please put this in a heat map, please cluster each grouping separately and then put it back all together. And that's what this function does. So I had another iteration called heat map by annotation. And in this case, I said I wanted it to group by state. And I added a argument to just basically name it. So that was easier here. And again, I could cluster by something else. So in this case, I said separate by the sex. And importantly for this, if you wanted to separate by something that wasn't shown in the tracks, you could. So even though sex isn't up here, I can still separate it because the annotations are all still linked. And so this function will cluster within each subset before joining them. And if there are subsets on and annotations on the rows, it'll do the same. So this was, again, a huge time saver because we used this all of the time and it saved so much legwork. But what about multiple grouping? So of course, the next thing is my boss took a look at this and said, okay, cool. Can you separate it by the connectivity and then the state? So that was the next wrinkle in this. So if I gave it another option to separate by connectivity and then state, I get this, it did what I asked it to do, but it was a little bit of a mess. So I had to add yet another layer to add options for gaps. So in this case, I have a vector of gaps, which is the same length as that of the groupings, that tell me how many gaps I want to put in between it. So I said I don't want to have any spaces in between my connectivity. So you can see, even though these are separated here, they're actually just stacked next to each other. And I wanted to increase the spaces between the states. So different, as more questions came up, I just had to continue expanding, but it ended up being very, very useful. And then the next layer of this was using these things for statistical analysis. So for both volcano plots and ANOVA, these annotations are already hard coded in, which gave me the option to just use them. So if I wanted to do a volcano plot, I could say, I want to do a volcano plot. I want to look at connectivity. Show me the difference between these two levels. And even if I had 4 groups in my animals and I wanted to just pick 2, again, everything was under the hood. So if I wanted to look for 2 groups within 6, then I could just state what that was and it would spit out all the statistics for me. And same thing with ANOVA. I could say I want to look at the statistical significance across connectivity groupings, give it a p-value threshold. And if I was to save this, the biggest issue I came with this at first was there's just so much information in ANOVA as there are with a lot of statistical tests. So in this case, if I save this, what I end up returning is a large list object that contains all of the different results that'll show you the F value and P value for everything. It'll give you a list of just which genes are significant and non-significant. And if you had a bunch, it'll also give you all the different Tukey on a significant difference post hoc analysis. So for me, what I ended up doing a lot is running an ANOVA and then just referring to these significant genes to make a heat map, and it streamlined the process a lot. So the real goal with this is just to make a useful package for beginners and experienced R users alike, because my lab, I came in not knowing much, but there's a lot of experienced users and there's a lot of people who don't know how to code much at all. So one of the things that was cool about this is ggplot allowed for like pretty extensive customization. So I made sure to keep it that way so that you could build on your plot outside of the function. So if we just have a base function here, which was again helpful for beginners who just wanted to make a plot comparing 2 genes, I could say, okay, just scatter genes with these 2 genes of whatever genes of choice. But if I was more advanced, this was the base function we just ran. And because it's still a ggplot object, each of these things can just be added or modified on top of it. So I just did all of this crazy stuff here by adding a different title, changing the background, adding a grid, and all sorts of different things. So if you know what you're doing, there's definitely a way to just continue to build on top of that ggplot object if you're not happy with the defaults. So this made a lot of the more experienced R users in my lab happier, just because they still had some control over those things, but didn't have to worry about all the legwork of melding the annotations with the data properly. And again, for the beginners, I actually wanted to make sure that there was a guide to recreate the plots. So if you wanted to recreate it from scratch because you needed to tweak whatever, I wanted to create an option to do that. So if I were to save the plot, this bee swarms plot makes what you see here. And if I save that and I pull out the plot input data, I get the actual data frame that is passed to ggplot in the function. So this incorporates all the annotations that we have, but it also is the melted object with the value in it. And then at the same time, I also have it returning the call. So if I give it the call, it will actually spit out the exact line of code that you need to recreate this plot. And a lot of these things are things that you have to give to it. If you put in the point size, that you would have to add that in, or different things like that. But a lot of the things, and there's a couple things I didn't show here for the colorings, all of that I've given in the plot object. So if you really are a beginner and trying to learn, this will tell you exactly how to recreate that plot. So flipping that around a little, what's under the hood, and this is really just why this package has been super useful to me, at least. We're starting with our data. Sometimes we might want to subset the data. We want to integrate our annotations, and we don't want to have to do it every time. We need to format the data for plotting, because whether it's melting for ggplot or doing something else for heat maps, it might not be in the right format to begin with. And that will give us our input data. And then with our input data, we have to adjust for whatever aesthetics, colors, and style we have. So all of that together, once we've done all of that work, we have this huge chunk of code for ggplot that will make our eventual plot. But with this package, instead of all of this work, you just have this one line of code. So that's kind of a summary of everything I have done. As far as expanding, there's a lot more functions. If you guys are interested, I have a pretty extensive vignette on GitHub, but the biggest things are what other functionality is important. So I ended up adding a lot of different options to these to reduce the x-axis or y-axis, or limit something, or if there are missing values, what to do with them and what other functions might be useful. So one thing my lab asked for a lot was a way to extract clusters. If there was a dendrogram and they wanted to split the dendrogram, can you extract the clusters to make a new annotation? And as far as publishing, the data set that's incorporated into the package had to be public first. I guess it didn't have to be, but it was our data in the lab. So I waited until it was publicly available to publish it on GitHub. And then Our Ladies has helped a lot with this. So the previous talks on dev tools and they use this packages is what helped me create it. So, and then I just uploaded to GitHub and users can install it straight from here as well. So that's kind of my story about how I developed this package during my PhD, and it's been really useful for my lab. And I've had other people use it on expression data sets too, and it seems to work pretty well for everyone. So, thank you.
We have a couple questions coming in, Allison.
Okay, sorry. Not looking at the chat while I was talking.
No worries. The first question is, what advice would you give people when making a package that is intended to be used by coworkers that are beginners?
I think the biggest thing is just documentation. It depends. I guess it depends too if you're a beginner and you're writing for beginners, or if you're experienced and you're writing for beginners. At least for me, the biggest thing came back to like, what's the easiest and most understandable way to do this? Because I came in as a beginner and I ended up learning pretty quickly, but because I had to learn so quickly, it was very easy to keep in mind just how lost I was at the beginning. So I think at the very least, making sure you document what you're doing so that anyone following along can understand.
That's great. And how did you return the plot call object?
It was sort of terrible and it took a really long time. I basically ended up having to go through and do it manually. So depending on what it was, a lot of the ggplot objects were built within the function anyways. So a lot of times, depending on what the different options were, I would continue to build it. So each time I did that, I also just saved the plot call separately as as a character vector, basically, or as a string. And sometimes I had to edit it a little bit so that it made sense, because if you look at it in actually as it is in the function and what it is, it's not quite the same, and then built on it. So that one took a little more legwork than I would have preferred, but I think it was worth it just because it was very helpful to the beginners in the lab who wanted to know how to recreate it. But yeah, I can talk to you more about it if you're interested, whoever asked that. But it was returning that was a little more legwork than I would have preferred, but I think it was worth it.
Awesome. How did you decide to make this a package versus just sharing some code examples?
It was
with your coworkers.
100% on accident, honestly. So a combination between being very, very OCD and lazy, which somehow ended up just turning into more work, because I originally just started off with a script. And especially for the heat map, I was doing the same thing every time. So it ended up being, I didn't want to keep hard coding it. So I ended up having a line at the top which said, okay, gene list here, and then run the next 6 lines. And I did that so often that I was getting tired of running the same 6 lines over again. So I sort of researched and learned how to turn that into a function, and it kind of just snowballed from there. Under no circumstances did I set out to write a package. It kind of just happened. But if you're doing the same type of thing over and over again, figuring out how to turn it into a function will save you a lot of time and heartache, I think.
Yeah, I think laziness is how I got my start into building up my first package too. It's just copying, pasting over and over again and realizing there's a better way.
Annoying. And then when I tell people that, they're like, okay, so you were super lazy, which meant you did all this extra work to make it a package. I'm like, yes, actually. But yeah.
All right, last one. What resources were helpful for you in the iterative process of developing your package, other than dev tools and use this?
A lot of it was honestly a lot of just Googling things, because it just depends on what your data is. And a lot of it just ended up being debugging. And I honestly went through and wrote out a bunch of flowcharts sometimes, just because if somebody asked oh, I need an option to do X, Y, or Z, some of them were really easy to incorporate and some of them were not. So a lot of times I had flowcharts just drawn out of what needed to happen in what order and what those options would be. So, But yeah, I mean, a lot of things was just Googling if something was possible or Googling an error. But yeah, I definitely just wrote out a lot of flowcharts to make sure I knew where things needed to go.
Awesome. Thanks so much, Allison. I really
Yeah.
appreciate you taking the time to share that today.
Yeah, thank you so much.
Let me pull up my slides real quick. All right. Next up, we have Jess Streeter. Jess is a senior data scientist at Spring Health. She has spent her entire career working on issues around mental health. When she's not coding, she enjoys spending time with her family, drinking good beer, and training jujitsu. I will hand it over to Jess for her presentation called Nerdify Your Life. Just a great title.
Fantastic.
Awesome.
This works so much better when you're not muted. So yeah, I'm Jess. I just want to talk you guys through Nerdify, which is our Spring Health package. I kind of want to just give you guys some background on it, how we even came to the decision that we needed a package, which is, I'm sure, a theme you will hear throughout all of the talks today. And then what we use our package for, what's incorporated in our package, how we maintain it and share it with everyone, and then I'll pass along a couple resources for you guys. So some background on the data science team at Spring Health. So I was one of the first 3 data scientists pulled into Spring Health. We've been around for, I think, about 2 years before they decided they had enough data to actually go for a data science team. They brought in a data science team. We were all pretty advanced in our careers at that point, and we basically had free reign to do whatever we want, which of course was immediately like, yes, we can design all of this stuff from the ground up. This is going to be totally awesome. We're going to get to do all these complex analyses. And we really quickly realized that no, everything is a hot mess, and we need to figure out some really basic stuff at the outset. And what we realized while we were figuring out a lot of that ground level stuff, a lot of these really basic data infrastructure, connecting to various systems, getting all of our data into a single space, the 3 of us realized really quickly that we were all doing the same things over and over. We were all making the same calls to the same APIs. We were all trying to sync with the same systems. We were all doing the same basic data manipulations, the same sets of cleaning. We were all messing around with ggplots to figure out what themes we liked, what our aesthetic should be, all of that stuff. So over the course of all of that, we kind of just got together pretty quickly in our tenure there. We're like, you know what? I think it's time to start developing a package, because it was just a lot of back and forth and sharing little code snippets. And after a week of that, you're like, no, we're not going to live like this. We're actually going to invest in developing a package with a couple things we use routinely, and then we'll have that grow over time. So why we thought a package was a great solution off the bat. The first thing, we could stop reinventing the wheel. The API calls for some of these systems and to get the data into a usable format was 100+ lines of code. And you'd have to pull up that script and input your parameters for it and figure out all your stuff. It was just really quickly became clear that this was very unnecessary to do manually every single time. It made routine tasks super easy. So I don't know, for some reason, the engineers that created our database really liked array data types for things that could have just been broken out into columns, and it was entirely unnecessary. And it would take us a ton of SQL code or a ton of R code to break this thing into actual usable columns. So instead of trying to do that every time, we just have something that automatically extracts the responses to a questionnaire, or extracts your responses to a specific form, or anything like that. It ensures consistency across the team. So we don't have one person producing charts with this color palette and another person's using a slightly different color palette. We're all cleaning data in exactly the same way. We're all making our manipulations in exactly the same way. It just ensures consistency. So if we start seeing things that are inconsistent, we're more inclined to like look at the data versus trying to troubleshoot individual code and figure out who went wrong and where. It also makes it really, really easy to quickly onboard new members. Instead of teaching them like, all right, so we have this database and there's like a couple of weird quirks and you always have to filter out these things, but never filter out those things. We're just like, hey, here's a package, here's a function. This function already does all the things you need it to do. This is our best practice. It takes way less time. We have to pass on way less institutional knowledge to get people up and running. And then the other thing that's been incredibly helpful, especially at a fast growth startup, is as our database changes and evolve, as our systems and as our processes change and evolve, we have to update the code in one place. We have to update the code in our package versus finding every place we did that API call and now changing that code and updating everything across numerous reports. It's all centralized, which makes updates, tweaks, modifications all incredibly easy. So next I'll give you guys an idea of some of the things that we put into our package. It really kind of runs the gamut of what we use it for. So yeah, I kind of try to bucket it into a couple of areas to give you guys a sense of what you can do with packages. So the first thing we have is all of our common connections. We have tons of systems that we interface with. So Bamboo's an HR style system. Acuity is a scheduling system like a Google Calendar deal. Mode is similar to like a Looker or a Tableau. We have Snowflake integrations, tons and tons of other integrations on top of these. We manage all of our integrations through our package and then through a system of environmental variables. So every data scientist is expected to have the same set of environmental variables. Obviously, like some differences depending on what you need or don't need. And as long as you have those variables present, all of your code will run seamlessly using your own credentials. And it makes those connections really, really easy to manage and maintain. So one example is for Mode. Again, this is a system where you can like create queries and then basically pull the data back from those queries. We created a function that would let you input the report token, your credentials, which would be environmental variables. And then we did some manipulations to make sure it pulled the object out of the list, created a data frame, and you were good to go. So again, these are just things that sort of make sure everything's uniform, help us expedite our analyses, and especially like this connection stuff makes onboarding really, really easy. Standardized style elements was the next thing we tackled. Again, because we were such a new team, we had a lot of input into how things should look, what our themes should be. And we realized like after tinkering, we should probably just standardize this and just have a couple of like real basic ggplot elements that exist as functions inside of our package. So we developed out a whole bunch of functions that deal with palettes that you can either use at like lower levels. So if you need a single color, you can put in like Spring Health Green and you'll get that exact green without having to know the hex code for it. You can pull out specific palettes for quantitative analyses, qualitative analyses, whatever you need a palette for. You can quickly view the palettes. A whole bunch of other functions like to that end to manipulate palettes, ramp palettes, select palettes, all of that stuff. We then have a whole bunch of ggplot themes. So Spring Health overall theme, and then we have a map specific theme since we found ourselves doing a lot of maps. And then we have just other ggplot style functions, scale color, Spring Health, scale fill, Spring Health. They just sort of, again, go back to those palette arguments that we've already created and make it really easy and seamless for you to quickly call the Spring Health palette, make sure you're using the correct fonts, make sure everything is basically set up in a way that you don't now have to spend all that time tweaking your ggplots. So this is one of my favorite uses of the code, is where you basically take things that other people built and then just kind of claim it as your own and tweak it slightly. So there used to be this package called the SFTP package that isn't compatible with like most of the new versions of R. It fell out of development. It was the best package I could find at the time to connect to our SFTP servers and get data out of it and upload things to SFTP. So when we all updated our systems and realized this package no longer worked, we were super, super bummed about it. The other thing was we started using a new SFTP system that used passkeys instead of username password combinations. An SFTP package was only set up to use username and password. There was like some hopes of adding passkey, but like I said, it fell out of development over time. So what I did was basically opened up that package on GitHub, stole all of the good bits, added the additional functionality we need, and now we have a version of that package that meets our specific needs, is maintained by us, and works exactly in the way that we need it to. So this was a huge win for our team for both of those reasons. And then the other thing that I'm a big fan of that we have in our image is systems that manage really complex processes. So the example I'll give you guys on this is we have what's known as the census. It's basically an eligibility file. We work with various companies to provide a mental health benefit. Those companies have to give us lists of employees and dependents so we know who's eligible for these services. For anyone who has tried to get a whole bunch of people to give you files in exactly the same format through a certain delivery system, you know it's like herding cats, and none of them will do any of the things you want them to do. So this becomes a massive process in and of itself. And initially, the data science team was only managing pipelines for really, really large partners with like 60, 70,000 employees and above, things that were too difficult for our care success or our customer success team to manage in Excel, which is basically what they were doing when we got there. So we started doing this, and the process is basically you have to go into the SFTP, find the most recent file, download that file, save that file to specific locations, potentially decrypt that file, clean that file to the correct format, run tests, upload that file back into our system, create all of this stuff. So a single pipeline quickly becomes a couple hundred lines of code at minimum. If they start needing more complex manipulation, you get like several hundred lines of code. So like I said, we started doing this with 2 companies initially. And then as we scaled, we realized, you know what, we obviously don't want anyone manipulating data in Excel, especially really, really important data. So we slowly took over our entire book of business and started putting everyone through this process. And instead of setting it up so everything's hard-coded every time, because every partner needs a unique pipeline because they all send us different types of garbage, what we did was create a whole slew of functions. There's probably about 20 or 30 functions just on the census in our package. And what it does is it manages this entire process while also allowing us the flexibility to do the unique manipulations that we need to do for each partner. So each partner may still need some unique cleaning steps. They may need certain subgroups created. They may need some feature engineering, whatever it may be. We can still do that with a couple lines of code, while the overall pipeline, all the way from connecting to the SFTP to creating those final files that are saved in specific locations, creating status reports, error reports, running the tests on the files, all of that is managed through functions in our package. So now what we have when you create a pipeline is basically an R script that's a template. It includes all of these functions as they need to be run, and then you can just plug and play and add the custom stuff that each partner needs throughout this process. So it makes it flexible enough for every single partner, but also well managed enough where if I need to change all 140 pipes, 200 pipes today, I can do it just by updating something in Nerdify versus opening 200 individual R scripts, which was a thing for certain things for a brief time, and I do not recommend that at all. So when it comes to actually sharing and maintaining a package, things we found is make sure the entire team feels ownership. We're all super proud of our package. We got hex stickers made and printed up. Everyone is welcome to contribute. People contribute to varying degrees, but we all really feel like we own it, which helps keep the package like alive and thriving and well maintained. Document everything. I am a stickler for documentation. So our package is extremely well documented. Every change, every parameter, examples, all of that stuff is all incredibly well documented, which again makes it really easy to get new people using the package. One thing we found super helpful is to have one person as primary on the package. So even though the entire team feels ownership, I'm the primary on the package. So if I hear someone say somewhere on our team, hey, I'm messing with this new system, I'm working on a new API call, I'm trying to interface with this new thing, instantly I'm like, hey, can we turn that into a function for the package? How can we incorporate this into the package? You just kind of have one person who's permanently a champion for the package, which is really helpful in making sure you have a strong package. And then we include the package in the new hire orientation. Basically, everyone that comes in, we walk through the package. We explain how to use everything. We show them the documentation. We show them what parts of the package are likely most relevant to the stuff they'll be working on. And again, it's gone a long way to making sure people can actually get up and running, doing analyses, getting data pretty quickly after they get hired. These are just a couple of resources for you guys. This package was the first package I had ever written. I think anyone on our team when we started had ever written. This first link is by far the most useful one. Like I literally just had that side by side up with my R script, and it walked me through everything I needed. And I'll still refer back to it if I have to do something weird. The next one has some really useful tips as well, including like how to add data to your package and stuff like that. And then something that sometimes gets overlooked, but you have to make a hex sticker for your package, and you can obviously do that in R. So there's a walkthrough for that, and I can actually share the code for how we made our hex sticker, so you can see that in practice as well, since clearly I can't share anything else out of our package. But yeah, that's it. That's what I do, guys.
That was great. Somebody said in the chat, but I'll just ditto, that was some awesome use of GIFs. We do have a couple questions coming in. So first one is, I'm curious, have you ever thought about splitting this into multiple packages? Better to create one big package or several smaller ones?
Yeah, so I've thought about it, especially for the census stuff, which is so unique to like one branch of work that we do that it could be useful. But I think my hesitation is I don't want to maintain two packages right now, so I'm kind of just keeping it the one. But yeah, it is something likely as we grow, there'll be certain pieces that'll probably be bracketed off into their own. But also like, I think it's just more for my OCD and organization rather than anything. Like, I don't see any reason why, like, functionally, I would necessarily need to separate them. Like, a new census package would have to call the Nerdify package to get other things that we need. So.
Thank you. And then I love that the package helps with onboarding, and you touched on this a little bit, but anything to add in terms of ways that you help new team members get up to speed and how you train on the package?
Yeah, I feel like it's tough because onboarding, so much information is thrown at you. So I kind of do it in like two stages initially. When they first meet with me, it's very much like, hey, we have this package. Here's high level, some things that it does, kind of basically what I told you guys. And just like let that simmer. And then as they get into their first project, it's basically like, okay, let's sit down, let's talk about a couple of things that are going to be most useful. That typically includes making sure they know how all the connections work, and how to use the package to access those connections and what environmental variables they need to do that. And then we also obviously like have everything on Git. So as people go through other folks' repos, they start seeing these things used as well. So I think we kind of give like a high level, a little more detail later on, and then let people figure it out on their own. But that's also because we tend to get very experienced R coders. So I think it's a little easier to kind of let people figure it out on their own without a lot of handling. If we had a lot of people who are new to coding trying to use this, we'd probably have a different approach.
Gotcha. And I think you just said you have it on GitHub, but there's a question about how you share the package internally. Is it in, enterprise level GitHub or, local zip folder or something like that?
Yeah, so we have it hosted on Git, but we also use RStudio Connect. So we actually have our package hosted in Package Manager on RStudio. And that way we all install from there, and then we can use the correct version of the package to deploy everything across all of RStudio Connect.
Awesome. And how do you keep track of, how do you keep the package up to date for users? Like if there are updates, how do you make sure all of them are using the same version?
Easier said than done. So on Slack, basically when I do updates, I'm like, hey, this is version X, this is the drop. These are the updates included in it. Since I both maintain the package and manage the entire census process, a lot of the updates are census stuff because I, like the rest of you who have built packages, am lazy and hate coding the same thing more than once. So I will very quickly put it in that package, which means a lot of our drops only apply to like the census group. So I just teammates who doesn't do hadn't updated in like 12 releases or something. But I'm also less concerned about that because if locally she has an older version, package manager will force the new version when she publishes. So it'll cause errors for her potentially, but it's not a huge concern in that sense. But yeah, you kind of can't guarantee people are running the right version. For certain processes, we'll make it clear too, like, hey, you need this specific version or above, or this will not work.
Awesome. And the last question, has your IT or security group raised any concerns about passing user credentials through your package?
No, so we don't pass the credentials through the package. They're in our R profiles as environmental variables. And then we just have documentation on how to generate those values. And that way they stay local. We specifically make sure nothing gets pushed to Git, or you don't accidentally like pass them anywhere. But after talking to like RStudio and like looking at best practices, environmental variables are kind of the best option we have. There's a couple of like keychain things and stuff, but we found them to be like limited in their reliability and stuff. So we just go with a good old R profile and some environmental variables.
Yeah, I know there's a package I use sometimes too called AskPass, and it'll literally like prompt you with the password input that's just like anonymized, so you can't see it or anything like that. It's not stored locally. All right, you've had this hiring page up for a hot minute, so I will let you give a quick plug for Spring Health. Share what you'd like to share.
Yeah, I totally forgot. I even had this slide at the end. But yeah, we're hiring for all data teams. Basically, we are growing rapidly. I was hire number 36 2 years ago, and now we've got over 200 people on board. Most of them hired in like the last 6 or 8 months. It's a phenomenal place to work. Most of our team is honestly queer women. So come join us. We're a fantastic group. I love working there. If you have any questions, you're more than welcome to hit me up.
Thank you so much. I appreciate it. We are going to pause and take a quick 5-minute break, and then we will come back for Jake Riley's presentation. Thank you, Jess. All right, welcome back. We are going to get started with our last presentation of the evening, where Jake Riley presents Rocky. Jake is a senior data analyst at the Children's Hospital of Philadelphia. He works with the analytics architecture team to provide centralized solutions for a large team of analysts. His work with Rocky has inspired development of other R packages, including Simple Colors, Shiny Objects, Headliner, Where Iation, and Code Reviewer. All of these packages can be found on Jake's GitHub. The link is right here. It's also in today's material document at github.com/rjake. Jake, you want to take it over?
Yes, thank you so much for letting me present today. Seeing all the work everyone has been doing is really just incredible. It's great inspiration. So let me just share my screen here. I think you'll see some themes as Carla pointed out. So yeah, my name's Jake Riley, and I was going to talk today about using R to reduce technical debt. I'll define what that means in a couple of slides. So my name's Jake Riley. I'm a clinical analyst at the Children's Hospital of Philadelphia. We also call it CHOP. So you're going to hear me say CHOP over and over again. These are some of the packages that I have been working on. Headliner is the new one in development, which I'm excited about. It's like a nice way to like title plots with like the so what of the plot. So it's like, well, what does it mean? Is it good? Is it bad that the number has increased? So it kind of like helps you describe that. Simple colors just lets you very easily just like grab color names that make sense. So like bright blue 4, bright blue 3, and the palettes all go together nicely. And the Shiny Objects is a package I built to debug reactive shiny elements. So the reactive objects are now like troubleshootable at the console. Those are 3 packages that are like top of mind for me, but I have a couple other that I've been working on as well. And my interest in package development really came from my work at CHOP, working on Rocky. So let me tell you a little bit about Rocky. So it's a weird name, RCQI. What does that mean? Well, our team used to be called the Office of Clinical Quality Improvement, and we built this R package to do that, and we made a hex sticker, which, as was mentioned earlier, is kind of like a rite of passage for package development. So we made stickers, printed them out, trained everybody, gave them to everybody. It's like a big point of pride on our team to have these. So even though the name of my particular team has changed to CHQA, we still are very proud of this Rocky package we all built together. So Rocky really helps us with our data connections, data visualization, our markdown templates, and also simple data sets, which make it really easy to troubleshoot and help each other. So let me tell you a little bit about how we got started. So technical debt, I grabbed this right from Wikipedia, but it's essentially the implied cost of doing additional rework. So if you choose a simpler, quick solution now, which might be copy pasting over and over again, that might cause you more of a headache later on if you have to go make a change to the 18 places you pasted some code. So copy and pasting a lot of code instead of using functions, hard coding things that can be soft coded. The reason I consider that technical debt is kind of the recyclability of code. So if you've hard coded, these are surgeries from May 2021. I can't really recycle that variable name if I only do the same analysis in the future. And then just being hard to read. So if the annotation is sparse, if the style is messy, we sometimes call that lint. It's like this, you need a lint roller to kind of clean up the aesthetics of the code. So messy style is technical debt. And then, object names that are maybe too abstract, A1, A2, it's like not meaningful and kind of takes more mental energy to revisit it. So technical debt is a big concept we talk about on our team. And so as we've looked for places where we think we have technical debt, we've tried to put some of those solutions into our packages. So the very first one that got us started was charts. So an SPC chart is a particular type of chart, and we'll get into a lot of the details on how to read them and everything, but it is a way to identify if the variation of a process has like the change in those values, is it like statistically significant? So, there's always going to be variation around a process and it dance along the mean, but if all of a sudden it seems like the points have increased and now have a new square line, is it statistically significant, or could that just be random variation? So SPC charts are a way that help us do that. So we were using QI charts too. This person put a lot of work into making, there's several types of SPC charts, and they made a package that does all of that work for us, but it didn't quite meet our aesthetics, and it just didn't have some of the flexibility that we needed. So we were piggybacking off of a lot of the code that they were doing. So we were like importing stuff and then kind of using this package called GG innards to like pick apart their to pick apart the plots and like kind of repackage that, or like we combine them in the way that we wanted. But yeah, the QA chart 2 package was really helpful and like a big inspiration, but it didn't quite meet our aesthetic needs. So yeah, we would like kind of grab pieces out of that and take the different data elements and put them into these. This is the high charter package, where we would just have to keep saying like, well, grab the center line, grab the confidence limits, grab the lower confidence limits, grab, like you're kind of grabbing all these things and adding titles and lots of list objects, and it's just like, it's very clunky and it was taking a lot of time. So we kind of use pieces of QA charts too, pieces of high charter, and now we just have this HC SPC function that does like it all in one go. So all of this code on the left is now just this short little code on the right. And we have a ggplot version as well, and we have a plot also because we're trying to move a little away from high charter because they're really strict around commercial licenses and stuff. Even though we're a nonprofit, it doesn't apply to us. We like that the Plotly, everything with Plotly is more open source. The second thing was just easy queries. So 98% of all the work we do in R still includes us touching our data warehouse. So we have a run SQL function, which uses ODBC connections to connect to the database, run the query, and then disconnect. So it used to be 3 steps in the past. Now it's just this one function. It does it all in one go. And then it's very common, like when the data comes back, it always has capitalized names. So we have a default of these names equals true. So we'll simplify it even further. You don't have to pass that. It'll just like come through by default. And then our default database or our default server even is our production server, but you can change the DSN to the production, our UAT environment, or development environment. And it's just like real simple to use this and use it in your dashboard. We also have a run SQL file function, which has almost all the same, does almost all the same stuff, except that it's pointing, it looks for a SQL file and then we'll run the code. And this is really helpful when we're prototyping. So maybe the table we want isn't like we call them automarts, but or like data marts will, as a project becomes dependent on a certain query, we will productionalize that and make that available in our data warehouse so it runs every day and is ready to go, rather than having a dashboard or something wait for a query to run. We're just waiting for it to like pull from that data mart that's populated every morning. But when we're in the development stage, maybe that automart or that data mart isn't quite ready to go. So you can just point at a SQL file to like bring in the data that you need, and then you can still prototype your dashboard even if the table isn't like in production yet. We also have a right to CDW table. CDW is our top data warehouse. And that's just another way that we can do some of this development, is to like knock something out, push it over to the database, and then you might like click something at it once we've done that. And another nice thing about all these is that they return tables. Just we like the way that they print out, and I think everyone's kind of expecting data these days to be tables. So it's nice that everything that Rocky produces will return a table. We have some really nice date helpers. So our fiscal year starts in July. And so if you want to do like a year-over-year plot that's going July to June, it was getting kind of tricky for folks to neatly make a chart that does that. So we created a fiscal month function, which if you give it a date, it will return a factor for those values going from July to June. So then it's really easy to just do a year-over-year trend analysis. And any data I show here is fake data. This weekend surgery data is just the fake data that we have available in Rocky. So yeah, we've got the fiscal month, and then you could also tell it to give it like a longer name if you wanted the full month name spelled out, or shorter. So it can kind of take any of those date formats that you can pass. I think it's from F or the format date. And any of those like variations, you can pass it to fiscal month and it'll return it, like it'll return it as an integer, it'll return it as November, NOV, and then it'll put it together as a factor. So that was like a really nice thing we added recently. And then we've got a fiscal year function, which is very simple, just return the 4-digit year, the fiscal year, so that it starts in July. And then we have a fiscal quarter function where you can, we see some different combinations of how people want to write fiscal quarters. So you can kind of give it, it looks a little funky here, but it's either big Q, the big Q is just like, I want the letter Q to show up, and then everything in the curly braces are kind of like placeholders. So the curly brace Q is whatever quarter is going to be returned, and then curly brace YY will be the 2-digit year, and curly brace with 4 Ys is the 4-digit year. So it looks a little funky here, but once you play around with it a little bit, it becomes very easy to format these quarters however is needed for documents we're producing. We also have this really nice function to make pretty tables ready to go for our dashboards and reports. So it really works off of good naming conventions. So anything that like links one table to another, we use underscore key. Anything that's a date ends with underscore date. Anything that's a 0-1 binary indicator is underscore IND. And then we'll often use like underscore MINS for minutes or days, years, weeks, hours. So that stuff goes on the end as suffixes, and we have a couple of prefixes like N underscore PCC underscore. So if those naming conventions are utilized, this one function called format data frame will make all these changes to the display of that table. So it'll drop all the key fields. All of the date fields will become nicely formatted, and you have some control over how it formats. But by default, it'll switch to down in the blue at the bottom. It went from the year dash month dash day to month slash day slash year. So it'll like do that transformation for you. By default, it's going to take all those IND fields. It's going to drop the IND off the end of the name. So sedation pathway indicator now became sedation pathway, and the ones and zeros by default just go to yes and no. Although you have control over maybe even say have, doesn't have, and if it's an any value to say missing. So you have control over what those values become. Yeah, and then it like renames everything for you too. So it uses title case. We have a word bank that gets utilized. So things like ED, which is the emergency department, always says uppercase ICD for ICD-10 code. That's like a ontology for disease. So like fractures have like a hierarchy to them, and all that is rolled up into ICD-10 codes. We're always talking about these features, and they just always stay uppercase. But then the rest of it becomes title case. So based on the naming conventions that the user uses, it will make all these transformations and retitle everything and be like ready to go. So we don't need to do a lot of rename until of our field. So this is I think definitely a heavy lift that we've made for the team. We also have a CHOP style guide. So there's design standards for the colors that get used in all of the like outward facing documents that CHOP produces. So like on our website that patients will see, there's a style guide. So we use the elements from that style guide into our package to make those styles easily accessible. So we've got CHOP colors. It's blue 1 through 8, brown 1 through 8, green, pink, and then we have a dark blue and a white that gets used as well. I know I think white is white, but it's actually got a hex code there. Yeah, so you can just pass it a vector of values, and then it'll just return all those hex codes. Sometimes people don't remember what grades the colors are, or some of them have little shortcuts like all the text is supposed to be this brown, and there's like this primary, there's this like primary blue color that gets used all over the place. So you can also use those names as well to bring these back. So sometimes people want to remember like which value is the text value. They can just say show CHOP colors to produce this plot for them. You can also tell it to produce it as a table and get the hex code if you're trying to like match it on like ClickSense or something, or some other document where you need to be specific about the hex codes. We also just make it easy to access some of our themes. So the default ggplot theme, I think it's very popular, but we don't really like the grid lines too well, and removing that gray background and just making it white, I think, gives it a cleaner look in some of the documents we produce. So we've got theme CHOP, and then for High Charter we have one as well, HC theme CHOP. And that also gives us our families and like the sizing of all of the text as well. So it's a little bigger and I think easier for folks to read. And then we have two scale functions as well for fill and for color that gets used with ggplot. And these are used all the time. And we usually recommend folks to do like set theme at the top of their script, so set theme chop, and then just all their ggplots will come through with the nice theme. We also have a couple of ready to go templates. So we've got a Flex dashboard template, and if you're not familiar with Flex dashboard, it's somewhere between an R Markdown and a Shiny app. It's just like a nice in-between place that allows you to build something that feels like a dashboard and is reactive, but uses the syntax of an R Markdown. So we've got a Flex dashboard template, we've got an R Markdown template, and then Shiny pre-rendered is like Flex dashboard on steroids. So it's much faster and reads a little more like Shiny than R Markdown, but still kind of keeps that R Markdown template. Like you would open a .rmd file to create a Shiny pre-rendered object. And if you're not really familiar with what I'm talking about with templates here, so if you were to create a new R Markdown, you would get to a screen like this, and there's 4 options on the left that most of us never look at. But the one on the bottom is from template, and there's all these templates that are out there that you can use for R Markdowns or Flex dashboards that are kind of ready to go. So so when folks go to create a new dashboard, they'll say from template, they'll go over here, there's 3 for Rocky, and they'll just select the one that they need. And then that's going to have a couple of things laid out in the outline of the document. So our dashboards are usually metrics in the first tab, patient detail, which will be a data table, and then the about page is like who to contact if you have questions and anything funky about, or maybe like what the denominator is of the data or like what's included in the cohort. The big thing is up at the top of the code is the YAML, which has all the details about like how it's going to be displayed. So we've got all of our CSS pointing at also hosted on GitHub. We've got a Bootstrap page that hosts is like where all the CSS lives. So we can just point it at those CSS files, and they'll give us a nice look and feel across all of our dashboards. So it's been very successful. Folks really love the way that these dashboards look and feel, and yeah, folks find it really easy to use. We have a couple of built-in data sets. We've got this ED fractures. ED again is the emergency department, and also one for surgeries, and that just gets used in all of our the help file documentation, all of our vignettes. We'll use them sometimes on Slack to troubleshoot different questions that are coming up, and we've made sure that there's a lot of the types of fields that folks are going to see in the data. So the hospital admission date, we're always looking at stuff related to hospital admission. So there's admission discharge dates, there's length of stay, because that's a question we get a lot. We've a lot of our projects involve those 0-1 indicators, so we have several indicator fields. There's missing data. There's just a lot of stuff that kind of mimics the data we regularly encounter, and it just makes it easy for us to troubleshoot. And what was fun about putting that into the package is I challenged myself to do it programmatically. So it just uses code to build these data sets. So there's no PHI at all, or there's no sensitive data. And then it just gets bundled up with the package and becomes this nice reference point you can all use. There's a couple other honorable mentions. So I talked about some of these when I was describing how the data table gets formatted. It's calling a lot of other functions to do so. One of them is nice display names. So again, that uses that word bank and some other expressions to just retitle things. So although in that example earlier, I was retitling the column name, you could just give it any vector or use it in a mutate, or there's lots of ways you could use it, and it will go through and like use that word bank and you know, use the title case to like replace values and whatever vector strings you give it. The read code indicator one is also really nice. So yeah, again, you would probably use that in a mutate, where you could say, yeah, if it's 0, say missing, or if it doesn't have, if it's 1, says has labs, and if it's an A, say missing, or you want to say yes, no, unapplicable. Like you can make it say whatever you want. So it's just really nice that yeah, we use those 0 1 indicator values so often, but they don't display well when we're giving one of our clients like an end product. So it's just a nice helper function. We also have this remove incomplete end dates that gets used. Again, we use that SPC chart so often, but if the month just started, it's common that the point could be in some extreme location because, whatever the thing I'm measuring is usually, hovering on 15%, but because there's only 1 of 2 observations so far this month, it's now pointing at 50% because there was 1 yes and 1 no. That can be really jarring to our end users, saying like, oh my gosh, that looks really bad. And you're like, oh, well, we've only had 2 days so far this month. So it's actually not, I wouldn't be concerned yet. So remove the complete end dates just says if the data is still in like this current month, then exclude it. Or it could be month, week, day, year. You can tell whatever period to look at. It defaults to month, but it's just a nice way to drop that data out of the data set when you go to plot it. So you would take the data, remove a complete end date, and then throw it into ggplot or something. And then we have this add date columns that gets used. So sometimes folks need to, they want to like floor one date field to a couple of different granularities. So we can say add date columns, and I think you can tell it which ones you want, but you could floor it to the day, the week, the month, the year. And so it'll just take whatever it is, like surgery date, and it'll say like surgery date, week, surgery date, month, surgery date, quarter, and it'll just like floor it all to that time period. So it's just a nice, easy way for folks to do that. And it can do many all at once, so it can like add 4 columns back for that one date instead of having to. There's a function in Lubridate you can do it off the floor dates, but what's nice about this function is they'll do it like for all. They'll make all those columns all in one go. So you can say I want days, months, and years, and then it will make a column for each of those. And so just a little bit about how it's done. So we have a prioritization process, which is it's very widely used on our team and also outside of our team in particular. So there's a lot of analysts at CHOP that aren't all, there's like a research arm of the hospital. And yeah, folks throughout the hospital can utilize Rocky. So we get issues regularly submitted, and then we have a monthly sprint planning meeting where we take those issues and put them onto a project board. So we use GitHub's project. There's a Kanban board you can use in GitHub. So we use that to identify like what is everything worth working on. So usually the answer is yes, but sometimes there's something that we've actually just fixed that maybe the user doesn't know about, or we want to point them at a different solution. So we'll go through all of our issues and say, is all this worth working on? And then we'll kind of divvy up the issues to different folks. And we're always encouraging new folks to join our meetings, which has been really nice. And so far we've merged over 248 pull requests over 33 different releases. So not every pull request becomes a release. We'll do a couple of pull requests, and then we'll announce like, oh, there's a brand new release. This one has these new changes or these new features. So we've had 33 of those. And then the maintenance is we work on feature branches. Then we commit that up to GitHub. We're using GitHub Enterprise, so unfortunately you can't download it. And then we have a really robust code review process that I feel like we've all just learned so much through just really thorough code review. And then it also kicks off a continuous integration process as well that uses a couple of webhooks in Jenkins. And what that does is it runs all of our tests. It also, there's the cover package, which is looking at test coverage. So like what proportion of the code base is actually being tested out of our test base. And there's like a certain threshold that needs to be met. So if that doesn't get met, it'll like kick back an error and say like, hey, like not, the package coverage isn't 100%. Like maybe write some more tests. It also does a little to check for the style, and it gets run through, I think we use Linter, and a lot of us also use Styler locally, and just to make sure that the style kind of remains consistent through the code base, and it also checks for spelling as well. And then that's just regularly we're regularly merging those into the main branch. And then we will periodically announce, okay, we've got a new release. And we have like CRAN, Chopperan. It's just the place that the packages get hosted. I can talk more about that if folks have questions, but you can, in your options, in our profile tell it like where to go looking for packages when you say install package. And so we have Chopran put on everyone's our profile. So when they say install packages Rocky, it will go look over there and download it for them. And then documentation wise, we use Roxygen 2. So some of the links that were shared earlier around package development, it'll probably mention about Roxygen 2. But if you're familiar with package documentation, I just wanted to point out that Roxygen 2 and package download 2 kind of like methods that we use for documentation. Yeah, and then in my last slide, the impact has been, we've had 18 authors, we have 3 maintainers. It's been a very collective enterprise. It's been a great way for us to share best practices with each other. It's made, I think, a huge impact on alleviating technical debt. It's reduced a lot of code that needs to happen. Getting the CSS on GitHub shareable in the YAML from our template just makes everything so easy to get this nice, consistent dashboard look and feel across analysts. Yeah, and then we've also contributed back to some of the packages that we're using. So we've done bugs to HighCharter, QI charts to and ggplot as well with bugs, feature requests, and pull requests even. Some of us have submitted code saying like, oh, I think this would fix things, and they've accepted it, which has been fun for us because I really look up to the Tidyverse folks, so to be able to contribute back to ggplot has been a lot of fun. So that's what I have for you. That's what I wanted to share about Rocky and how we use it at Job.
Thank you, Jake. We do have a couple questions. The first one is, can you explain a little more about how you created the templates? Are those templates added to the options by loading the Rocky package?
Yeah, so the templates get, I think it's under INST, I think is the folder for the package, and then there's templates, skeletons, I think, and then inside that you put the RMDs that you want to that you want your team to have access to. So it needs to be in a certain spot in the folder structure for the package. But once it's available there, when the user installs, when they install Rocky or whatever package you're working on, it'll just come along for the ride. So our Markdown package, so just in the screenshot here, like our Markdown package came with 2 templates that I can use. The Skimmer package has at least one that I can see here. The RepRex package has a couple of them as well. So yeah, just upon install, these will become included in the package.
That's really cool. You mentioned a word bank. Can you explain that a bit more as well?
Yeah, it's not anything that fancy. I think it's at this point it's not that big, so it's just hard coded into the function. It says like these 20 words are like reserved words, so when you come across them in the function, don't replace them. So I don't think I could like quickly explain it too well, but you take the words, and I think we just add pipes between them, keep them uppercase, and then say, if you see these words in the field name, don't touch them, essentially. Otherwise, make it title case.
Okay, it's just set of rules and some logic then.
That's all. Yeah, it's just a regular expression. So we just take the string of words and then tell it to keep them uppercase. I think we drop everything to lowercase, then title case it, and then put those words back to uppercase. I think is what happened.
Okay.
But yeah, it was a little involved to figure out how to do it, but it's all regular expression.
How did you create the custom Chop ggplot theme? Yeah,
that was a little before my time. I have to look into it. I have a feeling it uses theme replace. So there's an option in ggplot to replace and update themes, and I think it just uses that to say swap out some of these aesthetics. And I think that's it. I think it's theme replace.
Okay, thanks. And how do you decide how to name a new function? Short names are easier to type, but also can be inconsistent or confusing.
Sorry, could you just say the beginning part again? How to decide the name of new functions?
Yeah, how do you name these? How do you decide what name to assign to a new function?
Yeah, it's usually not just one person deciding a name. It usually comes up in code review where someone's like, this name's kind of confusing. There is a style guide for naming conventions as well. So if you look up the Tidyverse style guide, there are guidelines on how to name functions. So in general, they should be verbs, although not all words are verbs, but get this, remove that. Like the first word, from what we like to do, we try to keep it as a verb for what the action is. And then I think in general on our team, whether it's SQL or R, we've just decided to be explicit. So use longer names, although hospital admit date is longer than hosp admit DT. It's very clear what it is. It's very consistent. And like I showed earlier with that data frame format function, it if you use consistent naming conventions, then it gets like there's all these benefits everywhere. So it happens with our functions too. So we would just rather longer function names. We use snake case, so it just keeps it easy for folks to remember how it gets typed and that it's always nice spelled out.
Great. Two more here. So are there any people that are reluctant to use the internal package? If so, how do you convince them to get on board?
I don't think so. I think everyone board with it. It has so many hands in the pot. I think everyone feels like a special ownership over it. I think, we have those monthly sprint meetings, so the issues people do submit do get addressed. So I just think that there is a lot of folks are invested. Also, you can't get through on our onboarding process without using Rocky. You can't access. It'd be really hard for folks to figure out how to access our database without it. They could Google how to use the ODBC packages out there and stuff, but because Rocky has it all ready to go, I think folks are like, yeah. They'll at least use it for that, and then once they see kind of how the functions get used across analysts and across the onboarding, I think it just gets picked up really quickly. The biggest challenge I would say is learning about new stuff. So I think we could do a little better about shouting from the rooftops when new functions come out. But in general, I would say folks are excited to use Rocky.
And last one, can you explain Shiny pre-rendered?
Sure. Okay. So Flex dashboards. I really like Flex dashboards. I think they're really underutilized. It really just has the look and feel of a regular R Markdown. It's written just like an R Markdown, but you have access to some of the Shiny syntax like render plot, render table, the reactive, observe. You have access to all of those kind of elements of Shiny. However, it's not quite as fast because what happens when the user goes to open the dashboard, it runs the R Markdown, which means it's building all the UI in real time. So the UI meaning the buttons. So in this screenshot here, I've got 2 buttons. I've got three pages at the top. I've got a chart. I'm displaying source code. I've got a logo. So when it's kind of like knitting. I don't know if it's exactly knitting in real time, but it's kind of the best analogy is when the user goes to open the dashboard on our stuff is hosted on RStudio Connect. So the user will go there. They want to check, how is our number of beds occupied or something. That dashboard is kind of rendering all of that UI in real time. What Shiny pre-render does is in each chunk, like on our Markdown, each chunk you have to classify, is this a server chunk or is this a UI chunk? We call it the context. And so what happens is when you knit it, it spits out 2 files. It spits out an HTML file, or I think that's just it. It spits out an HTML file along with your R Markdown that you wrote. And what happens then is you push both of those or you deploy both of those to RStudio Connect. And because there's an HTML file, it's kind of like the UI is there's just a placeholder ready to go. So the navigation bar is ready to go. It knows that there's 2 input objects on the left-hand side. So all of that kind of has, like I said, a placeholder. So when the user opens the dashboard, it's not waiting for that stuff to render. It's already ready because the HTML has already been written. So it's a pre-rendered Shiny document. but then it still uses the R Markdown like formatting to generate. Hope that makes sense.
I think that makes sense to me. I think that makes sense.
Okay.
Don't see any follow-ups coming in.
Mostly, you would want training pre-rendered if your users are complaining about speed.
Yeah.
That's usually when I would suggest folks move over there.
All right, that's the last question. Yep, we got a thumbs up. We are good. Thank you so much, Jake.
Great.
I am going to
Absolutely.
take the
Thank you.
screen back for 1 second and just ask everyone to give a quick virtual applause for our presenters today. Alison Moss, Jess Streeter. A reminder that Spring Health is hiring. There's a link here, and there's a link as well in that tiny URL at the bottom right-hand corner. Thanks to Jake Riley for presenting Rocky. You can find him at, you can look him up on LinkedIn, and you can find his work on GitHub. He has multiple packages available on his GitHub. So that's definitely worth checking out. Thank you, everybody. As a reminder, we have that survey, the end of year survey. We do take any results submitted in that survey into consideration as we're planning our events next year. So if you take a couple minutes to do that, we really appreciate it. And we will have our next meetup in January. Thank you, everybody.